Good morning, everyone, and thank you for joining today's webinar, Accelerating Digital Transformation at Northwestern Mutual with Terraform and GitLab. Our speakers today are going to be Troy Fluge, Senior Solutions Engineer at HashiCorp, Mayank Tahil Ramani, Senior Alliance Manager from GitLab, and Sean Corkum, the Assistant Director of Engineering over at Northwestern Mutual. We really appreciate everybody joining today and hope everyone is healthy and safe. As a reminder, this webinar is going to be recorded and we'll be posting it to our website within 1 to 2 days. We'll also be posting a link out on social media. So during this webinar, feel free to enter your questions into the Q&A box down below, and we'll be answering them at the end of the session. And with that, we'll go ahead and kick it off with Troy. Go ahead, Troy.
Thanks, Peter. Good morning, everyone. First, what I wanted to do is just kick it off with a quick overview of Terraform. Terraform is an infrastructure as code tool used to automate infrastructure provisioning and compliance. It's a declarative language that teams use to have a common workflow across provisioning in their cloud and on-prem infrastructure. Many use cases, we see infrastructure teams using task-based ticketing systems like their ITSM tools to create new infrastructure. They don't start work traditionally until there's a ticket that hits their queue. Well, with Terraform, what we end up doing is being able to proactively create templates that allow teams to consume that Terraform infrastructure more of a self-service pattern, right? So you can end up servicing out these templates to your internal customers and your development teams. Today, we have over 200 providers, and you can think of a provider as a blueprint or a map to your infrastructure or your cloud provider's API. These providers are maintained particularly by the infrastructure teams or by the cloud organizations like Azure, Microsoft, and Google. Currently, we see about 100,000 downloads weekly of our open source Terraform. And we have about 300 enterprise customers and growing daily. Some guiding principles around infrastructure as code from a high level. Be sure to leverage tools like GitLab for your version control system. It's important to have your code stored in a version control system and have that be your source of truth for all your infrastructure configurations. Don't allow infrastructure changes really to happen outside of that standard workflow. It really enables you to reduce your human error and have confidence in your running configuration, knowing that what you have defined is actually what's in that in your running environment. Next thing I think pretty much goes without saying, automate all the things, everything and anything that you can automate. Automate that and have that code stored in your version control system as your source of truth. And also just be aware of our other open source providers or other providers that are out there. There's a number of open source providers. There's also a number of providers that you can use for both your on-prem and your cloud. I think we're looked at as primarily a cloud provisioning tool, but we do offer a lot of support for your on-prem infrastructure as well. We have many documented use cases, but probably one of the most compelling that we see for our customers is our multi-cloud compliance and management. Really having that central point of provisioning for compliance, it makes audits easier. Most industries have their regulatory compliance rules and frameworks that they follow. A lot of customers I work with follow NIST 853R4. If they're a retailer, they're following PCI compliance, and there's FedRAMP, HIPAA, CCPA. I mean, the list goes on and on. We also see customers following more descriptive config baselines like the CIS benchmarks. If you're not familiar with the CIS benchmarks and you're in one of the major cloud providers today, I really recommend you go look at that. Really gives you a more descriptive configuration on how you would secure your cloud platform. What we offer from a Terraform Enterprise perspective is Sentinel. Sentinel is our policy as code tool. You can think of it as being able to put in preventative controls within your automated pipelines or your workflows. We can fail those pipelines or those automated workflows if any of those violations or policies end up failing within your infrastructure as a part of it being created. So these policies can be stored in your version control system, just like your Terraform code would be, and managed just like you would any sort of other code through a standard software development lifecycle. This is something that I'll be just demonstrating a little bit later within the webinar. But first, what I'm going to do is hand it off to Mayank to go through some of the GitLab information.
Sure. Thanks, Troy. Can you confirm that you can hear and see me?
Yeah, I can hear you.
Okay, brilliant. Awesome. Thanks, Troy, for that intro. So yeah, I'm going to do a little bit of level setting and just some background on GitLab before we get started. Just to set the context, when you look at the traditional landscape of enterprises and organizations that are large, you see like a lot of friction across different teams that are siloed across various different BUs that are married to specific tools. And having specific tools isn't necessarily the biggest problem. It's having a consistent workflow across the different teams and enabling them to collaborate and becoming all cohesive in one. To really realize the whole DevOps cultural promise of being iterative, being collaborative, and putting together teams to work across different functions. So really, we're looking for a tool that reduces complexities and allows for a unified workflow with other teams that can automate the process. Because traditionally, they're doing work in a different manner. It's been doing large tasks over a long period of time where deliverables are months or years, just a few. What you want to do is to meet your moving point target, or once you do your requirement gathering and identify what the enhancement is, and before you start working on it, by the time you deliver it, by the time you've gotten all the stakeholders aligned and actually producing deliverables that add value to the business, that moving point target has already shifted. So what we're proposing is, when you want to realize the whole DevOps promise of being iterative and agile, you have to look at and do things differently, where you take smaller steps frequently, iterative approach to your optimal solution, so you're more precise in your target. This is a little bit abstract, and it's intended to be, but really to solve this problem is to get everyone on the same page, to get a unified workflow, which can be integrated with other tools like Terraform. And we'll discuss that in a little bit more detail. If you're familiar with GitLab already, it's a complete DevOps platform delivered as a single application. It does more than SCM, it does more than CI and CD. It's a platform where people can collaborate, where individuals can get from idea to production quicker. And that includes a breadth of features and functionality. So just like Troy had mentioned, where SCM becomes a cornerstone of the Terraform workflow, where you define and store your code, whether it's your Sentinel policies or your infrastructure as code, Terraform plans, that's where you store it. And that becomes your single source of truth, where everyone has visibility that's logged into GitLab and can edit it and update it and have a visible trail of all the deltas that are happening. And then from there, you can push it out into CI, which then triggers other workflows and other tools like Terraform to actually execute the plan, along with build the application and software code. Again, it's mirroring that with Terraform and GitLab. You're mirroring that the two different teams from operations that rely on Terraform and the developers that rely on software development on GitLab. But more than SCM and CI, there's security and CD built in too, whether you want to scan and make sure there's no vulnerability before you roll out into production. But another value add is, this is the whole software development process, but there's also the beginning aspect of the software development process, which is all about planning and getting a set foundation on what the idea is all about. So within GitLab, you also have functionalities like portfolio management, project management, task management, where you can build out your epics, issues, and burn down charts. And I think that's extremely valuable, because it's not just about software delivery, but it's also about the planning and project management of software delivery. So everyone, again, can be on the same page, communicate, iterate, and have transparency across the whole development cycle. So these are just a hint of some of the breadth of features that we have, all the way from cycle analytics to saying who's doing what, to plan effectivity of your teams, to all the way from service desk or Kanban boards to see how many milestones are being achieved every quarter or every month or every sprint. Obviously, many of you may have already be familiar with the create and verify stage and package stage, which is part of the SCM and CI/CD component. But there's much more functionality within GitLab, which can be configured accordingly to your unique workflow. But that standardizes it to be effective and consistent throughout the software delivery process. Just to give you a high-level overview of what that workflow looks like with Terraform and GitLab, or I would say HashiCorp and GitLab, the stereotypical workflow is as follows, where you have DevOps teams that includes your software developers, your operators, your system admins, your project managers, etc., are all contributing towards an initiative, right? Maybe a project or a milestone that is focused around a software enhancement that relies on infrastructure prerequisites to deploy. And that's where GitLab can define these policies in a CI template and these workflows in the business logic in the CI/CD component to trigger Terraform to then plan and apply and obviously validate with Sentinel policies and then provision that new infrastructure, while GitLab can then down line of that CI/CD pipeline deploy to that desired infrastructure. And this whole workflow, again, the value proposition is everything's defined in code, stored in GitLab, triggered and automated with GitLab and Terraform together to provide that consistency and reliability. And this kind of concludes the stereotypical traditional workflow with GitLab and Terraform. With that, I would pass it on to Sean, which will kind of show some of this in action. Super excited to see his demo. So I will go ahead and stop sharing my screen. Thanks.
All right. Can you hear and see me?
Yep, sound good.
Alrighty. So I'm going to talk a little bit about our journey here at NM and how we eventually settled on Terraform. So before everything kind of got going, like a lot of people probably on this call and at some point in our career, we kind of had that traditional on-prem data centers and everything was in there. And if we ever needed new resources, we had to go through this process of submitting a request, which then got sent to another team, got put on their backlog and prioritized, and the resources would be provisioned either manually or semi-automated. And this whole process could really take an extensive amount of time, like either a couple of days or even a couple of weeks. Sometimes there's different environments where these resources could only be provisioned at a certain time. We had all the manual patching that would go on, and there's always that wonderful little bit of doubt in the back of your head when that's going, and that yum update's going to run, and you're just hoping it reacts like it did in the other environments. Because with all this, everything stood up manually, you end up getting that little bit of drift between your different environments. And this whole process, this whole process is very inefficient, takes a lot of time. It's getting handed from person to person to person, and it really just kind of slows everything down. So at NM, we wanted to make sure that we really started, super focusing on, delivering value for our advisors and our clients, and trying to make as seamless of a client experience as we could. So we started going through this digital transformation where we really wanted to refocus, make sure that we're stepping back and what are the best practices in the industry now, and make sure that we started getting back on those so that we could deliver value to our customers at a very, very rapid pace. So we kind of knew where we wanted to end up. So to get there, we realized we needed to focus more on our engineers and outcomes. And rather than dictating how to get there, we wanted to empower our engineers to do engineering work. I mean, everybody's that's worked as an engineer knows we're really good at problem solving. So let's make sure that we're working on problem solving and not submitting requests for things to get provisioned. We wanted to provide the correct tool set to really, again, enforce this empowering of our engineers to get work done, to rapidly improve our agility so that we can drop our lead time to production and really, get value back out to our customers, our wonderful advisors and our clients and policyholders, even such as myself. We knew in order to kind of get to that pace that we really wanted to do, doing everything as code was going to be really important. It really allows you to free up a lot of things and get things going in a very fast pace. And again, as I mentioned, we wanted to make sure that through this whole process, we're focusing on our customers, both internal and external. And by that, I mean, our external is, our wonderful advisors and all of our clients, but also our internal ones. So if you're on a team like mine, where we're providing all the tool sets for the development community, we want to make sure our developers are having as best an experience as they possibly can. So some of the things that we did was we were already using GitLab. So moving on to GitLab CI was just a supernatural evolution of our process. Some of the things we loved about it were the fact that it was so scalable. It was cloud native. It's very easy to use and really empowered our engineers to do the things that they do best. And we provide, a lot of templates, some best practices to make sure like, hey, okay, all your scanning's automatically added. You're able to deploy in a pattern that we know that we can support at scale. But it also allows them that if they have to add like extra stages for something that's particular to their app, they don't have to go through some process of saying, hey, submit a ticket to get this done by some other team, wait for them to prioritize it, and eventually, maybe a week or a sprint later, it's in there. They can just do it. And if it's something that it turns out could be very valuable to the rest of the organization, adding it into the templates as we go is as simple as just making a merge request. From there, we'd originally started with Ansible and Ansible Tower to provision all of our resources, but our very own Ben Jaffe came across Terraform and started doing a POC of it. And to be frank, it just caught on like wildfire from there. It made doing infrastructure as code so much easier. We were able to follow the practice of creating our custom modules so that we could bake in security by default. And it was so easy to do. So now all of our users, anytime they need to spin up whatever AWS service or a couple of things that are patched together to make a certain kind of product, they know that they can just copy in that module, add whatever little variables that are needed for it, and it's compliant. They don't have to think about like, oh, do I need to make sure I have this on or that on? Like it's on already. Our resources are able to be provisioned now within minutes, and quite frankly, even very large and complex whole environments can be done in under an hour, where before that could have easily taken a month to get everything together and wired in, and then go back and make all the different automation to tie everything in. It's really freed everybody up to do the work that delivers our value to our customers. Kind of a side bonus from this whole thing is our environments are super reproducible now. And you might be wondering why that's important. Well, think of it this way. If you have an environment and something's going wrong and people have to SSH in and do some manual firefighting to return functionality to normal. With how we have things set up and using Terraform, we're able to take that environment before these manual changes and make a perfect copy of it. We can now then go back and really dig in and find out what root cause is, and then take a step back and figure out what's the holistic solution, apply that, and roll it through all of our environments as we rehydrate. It's really freed up a lot of things to make sure that we're able to really enhance our stability and keep everything up and running as expected by our customers. So after all these changes have kind of taken place, some of the things that we've noticed are obviously our lead time to production is drastically improved from where it was before. With entire environments being able to be created under an hour, it makes things so much easier. We're not waiting weeks. We can get the resources stood up, start deploying code. We're good to go. Everything's done and going in a day. Our engineers, again, are empowered to do the things that they do best. They can just get their work done. They don't have to sit there and wait and, like, okay, well, I'm waiting a week for this to get done, so now I'm going to context switch over to this. They can just hammer through, and applications can now move from idea into production in hours, really, if it's something easy, or even if it's something more complex. Our cadence is days, gone. We don't have to think about the days of having to do, that yearly, quarterly, even monthly kind of release cadence. It can just go. Is it ready? Did it pass through all the automation steps? Is everything up? Boom, done. Start, giving value back to our customers. And a lot of that, again, helps, with everything being as code, ties back to allow that to be done. Our environments are, easily reproducible. We can create them for, off on the side for testing this and that, finding, any kind of bugs to improve any kind of stability that might come up. We don't have the risk of patching anymore. So there's gone are the days of that thinking like, oh, when that yum update runs, is it going to work right? Is everything going to come back? Because you take this rehydration approach where I know that AMI in the test and dev environments are exactly the same as what's going to go out to prod once we've got everything checked. You don't have to worry about it. It's going to come up. And that's really kind of helped us to go along. So moving on to something a little more interesting, we've got a little sample Terraform config here. And I thought for fun, we'd kind of show a standing up GitLab in, not exactly as simple, but not super, super complicated. So in this config, we've got a bunch of the different AWS resources that will wire into an omnibus installation. So you can see we've got the EC2 TF, and that's just our omnibus package installed in an AMI. We're going to leverage Elasticache for Redis. We've got an ELB for the load balancer. We're going to use ACM, Amazon Certificate Manager. That'll create the SSL cert and attach to the ELB. RDS for the Postgres, Route 53 for DNS routing, S3 for artifacts, uploads, LFS, backup buckets, and etc. We've got some security groups to help make sure that we're locking stuff down, and an SNS topic to allow for alerts. So as CloudWatch comes up with something, we can make sure that the alerts get paged out to the right people. As we go on, here's kind of the EC2 file. As you can see, we're using one of our custom modules that allow us to make sure that all the little security bits we need are baked in. Some of this, if you're using this in more of a production environment, you'd want to variabilize out a little more, like the name, the instance type, things in the block device. But what's kind of fun with this one is we're going to leverage user data in order to do some kind of last mile runtime configurations. So as you can see, it's got a little extra var section where we're getting things like the Route 53 output of the fully qualified domain name, the Redis DNS, the S3 buckets, some of the Postgres RDS instance information. And that information gets passed to the script. And then as the EC2 comes up, it updates the GitLab RB file and adds those values, and then does a reconfigure right at startup, so that once we stand up this environment, everything gets going and it's just up in one shot. But let's say we need to make a little change for some reason. Let's say the EC2 needs a little more horsepower. Super, super simple. Like in this case, you can see we're changing from an M5 large to an extra large. So we just open up the web IDE, make the change, commit it to a branch, submit our merge. Once that's approved, see the pipeline pops up at the bottom. So we've got just a little sample of the Terraform plan showing it's changing from an M5 large to an M5 extra large. That runs through, the plan applies, and we've got the change going. So we can just hop back to the DNS to make sure it is up and running. And there we go, GitLab Enterprise up and running with no manual configuration, just all automatic. So with that, I'm going to pass it off to Troy.
Thanks, Sean. Let me get my screen shared out here. I've been working with Northwestern Mutual now for a number of years, both on the practitioner side and now on the vendor side of things. And it's really exciting, honestly, to see some of the innovative things that they've been doing there. I know Sean focused in on deploying GitLab itself as part of his demonstration, but that's literally how all of their cloud infrastructure ends up getting deployed through that common workflow. What I'm going to do is kind of take that a step further and show a live demo of how that would end up looking, integrating directly into Terraform Cloud. And we're going to run some custom Sentinel policies through this as well to do that more preventative security controls around what you're actually introducing into your cloud environment. So what you can see here, I got a couple different tabs up. I have our normal AWS console up with a quick filter here just for a VPC that we're going to end up deploying. I have a real simplified project here, just going to deploy, it's going to have one module, a networking module in here, that's going to just deploy VPC, some of your common networking requirements, an internet gateway, some subnets, and some other things. Really wanted to take some of the complexity out of this just for the sake of time, but fairly simple, and it'll deploy pretty quickly here that we can demonstrate what this looks like. And the other tab here I have open is a set of Sentinel policies. And like I mentioned earlier, Sentinel is going to be your policy as code. This is going to be the logic that you're going to send your workflow through, your Terraform workflow through to make sure that your modules and your what you're about to provision is meeting your requirements, whether that be from a security and compliance standpoint, or maybe from an availability and resiliency standpoint. In this case, I just have a couple of policies out here. The policies here are tag validation, just to validate that we have the appropriate tags on our resources. Ends up becoming critical if you're deploying things into AWS to make sure that your teams are tagging their resources efficiently, whether that be for cross-charging, maybe for different types of environments, ownership. There's a number of really good reasons to make sure that you're doing the appropriate tagging. We have one in here for quad zeros to make sure that people are not just making things public. And we also have one here for restricted AZs. You could do the same thing for regions if you had like data sovereignty type rules where you had to keep things within maybe the US or the EU. The reason I had 3 policies here is just for to demonstrate the different enforcement levels. Enforcement level here is hard mandatory for our tag validation, which means that if something violates our tag validation rule, it's just going to automatically fail the pipeline. It's not going to allow them to pass any further. The quad zeros we put in as soft mandatory, which means you could do an administrative override with that. An advisory is just that. It's going to advise them within their workflow to say, hey, you shouldn't be deploying this in this fashion. You should probably be doing something different. Now, obviously, these enforcement levels going to be different based upon what your requirements are. I just threw 3 rules in here with 3 different enforcement levels to demonstrate what your options were. The policy that we're going to be looking at as part of the demo is this tag validation policy. And really the meat of this policy is right here at the bottom here, right? We have a list here of tags that we want to be provisioned on our resources. And then within each one of these function calls, we're going to say, we want to validate that this VPC has the appropriate tags, which are defined in my list. And that goes down for each one of your resources. So you could theoretically have different sets of tags for different sets of resources as well. So it's quite a bit of flexibility here. The other piece I'll show here is the GitLab CI file that we're working with. Again, pretty basic project. We have a number of steps here. And if you used Terraform before, you're probably pretty familiar with a plan and apply and your destroy. But we do have a validate here just to validate our configuration of our Terraform. And then we'll have another stage in here to make sure that validate ran as a dependency, and then go ahead and run that plan and tell us what, if you're not familiar with Terraform, that'll tell you what we're about to deploy if you ended up doing an apply. The apply step is what's actually going to go out to the cloud provider and do the provisioning of your cloud infrastructure. And you'll see that we set this one to manual, again, just to demonstrate some of that flexibility. And then ultimately, you can end up going and doing that destroy as well. Obviously, just as easy as it is to create something, it's just as easy to destroy it. So whether you put something like this within an automated pipeline really is up to your organization and how they want to do that. The other tab I have here is Terraform Enterprise itself. So the way GitLab is going to be working, GitLab is actually going to be calling out to Terraform Enterprise to do those plans and applies. And Terraform Enterprise, or in this case, Terraform Cloud, is going to end up doing the validation of those Sentinel policies also. So in our settings here, if we look at our policy sets, we have our GitLab Sentinel policies that we have applied, and that's going to point right back to that GitLab repository that we have with those policies that I was just showing you. In this case, we do have some options to assign those policies to all the workspaces that we have applying, or we can apply that policy to just the selected workspaces. So in the case of this demo, we're just applying it against that selected workspace to run that policy. So now, since everyone kind of has a basis, kind of a foundation of how this is all wired together and how this is configured, what we're going to end up doing is going in and violating one of the policies themselves. So in this case, you can see that we have our tags. There was 5 mandatory tags. One was for name, which is up here. And then we had other ones down here, which are all part of the mandatory tags as well. So if we go ahead and comment out one of these tags to get that policy to fail, we can go ahead and commit this change. And just for simplicity, I'm doing this right through the web editor. And you'll see just that change itself to that file ended up kicking our pipeline off. And at first it goes through a validate, which is that first stage that I was showing you within our GitLab CI file. And it's going through and just validating that particular configuration. That has passed, we've gotten that check, and it automatically went into the plan stage. In this plan stage, you'll see the identical Terraform output that you're used to seeing, but you also get this link in here to say to see this run in the browser, because something to be aware of is this is actually doing a remote run on Terraform Cloud. So even though you're getting this output within your workflow, within your pipeline here, it's actually going to be running here in Terraform Cloud. So you'll end up getting the same output as part of this. So here is our plan. Here's an additional feature we get around cost estimates. Since we are deploying just core network infrastructure, it's not going to come up with any sort of cost estimate. But if we were to deploy an EC2 instance or any other sort of infrastructure that has that initial cost on it, it'll end up giving you an estimate on what that run rate would be. In this case, you'll see that we ended up failing our policy check. And if we scroll down here, you should see right here. Here's our hard mandatory failure. It went to false. It's coming back telling me all these resources failed to have a compliant tag that was required. So we ended up doing a hard fail on that pipeline. This is what that would look like within Terraform Cloud, but you'd also get that same failure here within your pipeline. So from a developer experience perspective, as part of that pull request, and as part of that pipeline run, they would end up getting that failure, and it would tell them what failed, and they would have an idea of what they have to go back to fix. So the important piece to kind of get with this is that you can write your compliance, your regulatory compliance policies in alignment to what's required as part of the provisioning process. So instead of submitting tickets back into your security team to do security assessments on your application prior to deployment, and then waiting weeks potentially to have that security assessment done through kind of an old kind of paper pushing process, you could write those policies and have those validated dynamically right as part of a pull request in your pipeline. So we can see that this failed, and it's not going to let the person go past that point. We're also going to see that failure here within Terraform Enterprise. And again, no one's going to be able to get past this point. What we're going to do now is just go back and fix the problem that we had, because as a developer, that's the first thing you're going to want to go do, because we want to test our code. I'll go ahead and put this comment back in here. And you're going to see that same workflow go through again. Again, you'll see our pipeline's running. Our validate passed. Our plan is now running. And if the demo guys are with me, this should run through. Here's our URL again, if we wanted to go out to Terraform Cloud and actually see that run out there. I don't think I mentioned this before, but we should see a cost estimate actually come through as part of this as well. You'll get that right within your pipeline. So if the development teams had budgetary constraints or anything like that that they had to stay within, they would get that cost estimate right directly within that pipeline as well. Here it is. So here our policy passed this time because we have our required tags. All of our resources have the required tags. It's all set to true in here. So our job succeeded. And if you remember within our pipeline itself, we had our apply stage set to manual. So we have our check mark here for our plan, and we can go ahead and run our apply. So it's running. So if we go back out into Terraform Cloud, you'll see that this workspace is already in the planning stage. It just automatically got kicked off as part of that pull request. And again, you'll be able to see that apply directly right here within the console. And it'll run through the same steps here that you'll end up seeing through here, with all your policy, Sentinel policy validation being processed out in Terraform Cloud, and in this case being validated. So we just give this here a few seconds. Yeah, and you can see the creation of our resources. We got some subnets that are being created, the VPC that's created. Our job was successful. We should see that successful in our Terraform cloud as well. Likewise, you'll still see the cost estimate if we were deploying some EC2 instances or some resources that had a cost directly associated with them. You'll see our policies that have failed or passed. You'll see that we have an advisory failure. I did this on purpose just to show that we can still have advisory failures in here, but still have the job run. So if you wanted to notify teams that you're maybe deprecating a setting or something similar, you could put advisories in there and then notify people that they would end up having to change that at a later date. This becomes pretty popular when you're looking at doing module versioning and making sure that if you're deprecating old versions and rolling in new versions, that you can give people a chance to be able to update to that newer version of the module. And then just as easy as we went ahead and created all of this, we can go ahead and destroy it just as quickly. And just as part of that destroy, we should see this GitLab Demo workspace kick off automatically from applied to provisioning. Oh, thank you. There it goes to planning. And again, it's going to go ahead and just destroy everything that we created. So here's the VPC that we created just within AWS console. And as this destroy is running here, you'll get the same output that you would from a destroy. You'll get that within your pipeline as well within GitLab CI. All of your resources being destroyed. And then ultimately, you should see the resource disappear. There it is. That's really the demo that I had. There are a few other things I wanted to cover as part of this. Let me share out a different screen. As part of our Terraform adoption, we typically see our customers start at the far left of this organizational complexity curve, right? They start at the open source. They start using the open source CLI tool. It's easy, pretty straightforward. It's a single binary you can download and start using today. And then typically that works pretty well when you have a team of a handful of people. Once you start sharing code and having a local state file scattered all over the place, it ends up becoming a lot of complexity with that. So typically, as that complexity grows, as you start to scale this out to an enterprise scale, maybe with multiple teams or multiple departments, people start coming back to HashiCorp to ask, how can we operationalize this? What does day two look like at more of a larger scale within our organization, or maybe even when we get to more of the strategic point where we want to do self-service? That's where they come to us and start talking about our enterprise tools. As part of our enterprise packages, like I mentioned, our open source is completely free. You can download single binary. I encourage everyone to download that, start using it today. We also have a free account with our Terraform Cloud. It's a subset of features that you can get, but it's another thing that you can create and run through some of the stuff that I demonstrated today with the exclusion of the Sentinel, the policy as code aspect. That would end up coming with our paid features within Terraform Cloud under our policy and governance. And then we have some of our other customers that prefer to run their own infrastructure for Terraform. So instead of using that SaaS service to really deploy their own Terraform Enterprise infrastructure themselves and to manage that, and they would also get that Sentinel aspect of it as well. And then as part of just kind of a closing comment here, prior to handing it back to Peter, we just want to give a reminder to our cloud operating model. If you're not familiar with the HashiCorp cloud operating model, I encourage everyone to just Google HashiCorp cloud operating model, take a look at that. Today, we did a lot of focusing on Terraform automated provisioning and policy as code, but we do have Vault for securing our secrets dynamically and doing dynamic secret rotation. We also have Console for service discovery and service mesh, and then our runtime within Nomad for scheduling of our services. So I highly encourage everyone to take a look at that, see how all these services work together, but also keep in mind that you can use them individually as well. It's not a requirement to use them all at once. So Peter, with that, I think I'm gonna hand it back to you.
Awesome. Thank you so much, Troy, Mayank, and Sean. At this time, we're going to go ahead and open it up for questions. Troy, while I have you on here, I did get a couple questions about Terraform state files. Can you maybe just walk us through what some of the different options are for how you can store and manage your state file, basically kind of along the lines with what you just talked about in terms of packaging?
Yeah, within Terraform Cloud and within Terraform Enterprise, the state file is going to be managed within Terraform Enterprise or Terraform Cloud itself. Now you can choose to have that backed with S3 if you prefer, but that managed and that state locking itself is going to end up being managed and controlled by Enterprise or Cloud.
Excellent, thank you. One of the other questions that came up is during your demo, which image of were you using on your GitLab CI pipeline?
The image, so it's running a GitLab CI runner that's running out in AWS. So it wasn't running. I'm assuming you're referring to whether it was using a Docker image or not, right? I'm not actually using a Docker image. It's just using an EC2 instance out there right now.
Thanks. Mike, so I mean, we had some questions just like kind of about the general flow of the presentation and like how much, the different integration points. Where could people go if they kind of wanted to learn like a little bit more about some of the different ways that you can use GitLab and Terraform? Because obviously this is a couple of specific use cases.
Yeah. So there's a lot of resources, and I'll link a few on the chat as well. But shameless plug, I'm actually doing a Twitch stream tomorrow with HashiCorp Live that'll actually walk you through in a lot more details around this use case, which actually includes Vault in the mix as well. So check us out tomorrow at HashiCorp Live. Not tomorrow, on Friday, March 20th from 1 to 3 p.m. where I'll actually walk you through how to integrate a demo application that I have with Terraform Cloud and use Sentinel, basically the demo that Troy showed, but really the configuration aspects behind it as well. So when we talk about integration points, right, there's some best practices or recommendations on which CI runner to use during the CI job when you're executing Terraform CLI, and same thing for Vault as well. So we'll walk through what that CI pipeline looks like. We've got a Terraform template itself within the product. So when you create your CI file for GitLab for your repository, there's actually a drop-down template with Terraform predefined to get you started quickly. Additionally, there's a lot of work going on where we're trying to integrate the products natively much more intimately. And you can find that online in our directions page. We're a fully open company. We're very, very vocal and open about our product roadmap and what we're intending and hoping to do. Some of those features revolve around Vault, and there's some features coming in the pipeline around Terraform as well. There's an infrastructure as code epic that you can check out and track our progress on as we iterate towards making these types of workflows, infrastructure as code and GitOps workflows a lot more native with Terraform and Vault and Sentinel. And I'll provide those links in the chat shortly.
And I think that's an important piece too. Just like I mentioned before, you can use all the products together or you can use them separately, but integrating Vault into your pipeline to start managing AWS access keys and those types of things obviously becomes critical with all the issues that you see if you hear people committing their access keys into public GitHub repositories or GitLab repositories. It's a big issue. So being able to dynamically check those credentials out as part of your workflow becomes critical.
You went ahead and answered one of the questions we had about taking care of permissions for resources, Troy. Thank you. So yes, using something like Vault is a good way to kind of manage access to those. So Troy, along those lines, we also had a couple questions about rolling back infrastructure or rolling back to previous states. So one of the questions was essentially like, how does Terraform handle that just in general? And then also, is there anything for like automated testing to see like if something was like bad that was deployed, or like could you use anything like Sentinel to be able to kind of put in those restrictions just to make sure that if you have to roll back, can you? And then two, is there any way to just make sure that you can prevent that from happening where you'd have to do a rollback?
Yeah, I mean, you can always revert to a previous commit, and just the way your state files management is going to be different versions of that state file. So every time you do a provision any sort of infrastructure, right, it's going to convert that template into a state file while it's provisioning that infrastructure out in the cloud. And then it keeps that state file in sync with what infrastructure is actually out in the real environment. So if you were to have to revert something, let's say you wanted to remove an extra instance or something that wasn't intended to be out there, you could go in and either revert that commit and then have that recommitted in, and then that's going to revalidate what's within your state and what's out in the cloud, and then basically make it consistent again. So if you ended up adding something extra and then reverting a commit, it should go ahead and remove that when it resyncs the state again. As for automated testing, there's a number of things that you can end up doing as part of that, and that's what you can do as part of the plan, right? You want to make sure you're running a plan and make sure you know what's going to get provisioned prior to being provisioned, and just make sure you're doing that before you apply. But I'll have to look in and see if we can find some additional things on more like automated testing. I guess I'd want to dig into that question a bit more. And see where they're
We
going.
haven't really started using this much, but I've played around with it some myself personally. There's a product out there called TerraTest, which kind of does, it's meant as like unit testing for Terraform. It's all Golang based. It's something I've played around with a little bit with myself. It seemed pretty interesting so far.
Cool. Sean, while I have you, one of the questions that came up is they were asking just generally, are you following the coding standards for Terraform? So I'm imagining that they're asking, like, are you using HCL, or are you trying to do this, like, do a lot of your modules using like JSON or something?
No, we're following the HCL. It just makes life a lot easier. No need to reinvent the wheel.
For sure. All right, take a look. We have a number of questions coming in here. So for the gentleman that asked about intro guides, yes, we do have intro guides. If you go to learn.hashicorp.com, we have a number of guides for getting started with Terraform. Walks you through how to use it with our AWS and GCP providers. Should help build some additional confidence, as well as we have a number of other kind of cool walkthroughs to be able to help get you started. I'll throw this out as a general question for everybody, but and you know, Sean and Troy, this is kind of for either of you. Do you recommend using subgroups for different environments, so like per application, or like what's the best way to kind of integrate pipelines across environments?
I mean, I would probably say, keep it on, work off the trunk, off master, or whatever you decided to call it. Within GitLab, at least in GitLab CI, you can define different environments for each stage. And that's probably a pretty good way to go, because then you can go back and there's that, tab on the side that says operations, and you can see what was deployed to each environment real easily. That's probably not a bad starting spot for a lot of people, at least.
Yeah, and then just from a Terraform general perspective, just to leverage modules, right? Whether you're using those modules from the public repository or writing them yourselves for your own organization, just consuming those same modules consistently between the environments and then passing in parameters to those modules as you start to progress through the various environments, because then you can just be confident with the consistency that you're getting within the various environments that you have.
Thank you, Rob. Mayank, actually for you, can you talk a little bit about like the workflow integration between Terraform and GitLab?
Yeah, it's very similar to what was shown by Sean and Troy, right? That integration is purely focused on how you define your logic in the CI pipeline and what commands you want to run with Terraform. With Terraform Cloud, there's a webhook integration. So every time the CI pipeline kicks off, it basically triggers Terraform Cloud to look at the VCS integration that's been pre-configured to pull from the code and then execute accordingly. So the workflow is pretty flexible, but once defined by code in your infrastructure CI pipeline, then it's pretty much reliable and set. It's repeatable. And also, I'm going to provide one additional link. This is actually a blog from GitLab. We use Terraform internally at GitLab, and this kind of shows a little bit of insight of how we use it, how our infrastructure subgroup uses Terraform to provision our infrastructure on GCP. So I'll provide that for some additional context and offline reading.
Troy, this was a question that came up asking if you could use a similar type of workflow with Oracle RMS database and applications that are running on VMware.
We do have a provider for VMware, so I'd recommend you pull that provider down, go through the documentation. and see what resources you can provision from that provider. Like I mentioned within the talk that we have, I think we're just looked at, I mean, we made the cloud number 4 in the cloud 100 list or whatever from Forbes. I think we're just really, HashiCorp's looked at as a cloud automation tool, but we do have a lot of providers out there for your on-prem infrastructure, including VMware and Palo Alto and Cisco ACI and a lot of your main on-prem infrastructure tools. So I just really recommend that people go out and look at what providers we have and see how we can automate those workflows like you would out in the cloud, but using the kind of the same concepts on-prem.
So one of the other questions that came up was around the tagging example was popular as far as part of your demo, Troy. So one of the questions is that, like, how would that translate to like a containerized environment? Like, could you use it to have like tagging single containers? Basically the goal would be like, if you want to have like a different cost center for each container, just so you had a better way of tracking that in your deployments.
Yeah. If it's a resource that has a value in which you can put a tag on it, like for instance, out in AWS, I mean, you'd be able to put a tag value on that. Now, if you're talking rolling out Kubernetes clusters and then rolling pods out with containers within them, you probably would end up going down some sort of like metadata label or something like that within the container, which we do have a provider for Kubernetes. We would end up having to look. I'd recommend looking at that provider to see if you'd end up being able to do such a thing. You should be able to. I don't see why not. But I would start thinking about how you're going to end up doing chargeback if that's what you're thinking, right? Because now you're talking microtransaction of a host itself. That could get pretty complex pretty quick.
Another question that came up is that, would you be able to provide any of your example code from your demo today?
It's public today right now out in GitLab. So if people want to go grab it, they can. Like I said, it's pretty simple. All it's doing is creating a VPC and some subnets. I wanted to keep it short just because of the time constraints. Yeah, but anyone's welcome to go out and grab it. If you have questions, you can always email me. I thought I saw one out here too. Someone asked if you could create an AWS region and easily change it without destroying and recreating. No, that's something that's really going to be up to the cloud provider itself. And if the cloud provider doesn't give a method in which you could easily move something from one region to another region, we're going to end up being bound by whatever their requirements are. So in that case, what it would be from a Terraform perspective is when you do that plan, it would come back. If you change the region within your template and you ran that plan, it would come back and tell you, hey, I can put this in this other region, but I'm going to have to destroy the resources that are in the original region first. So it's not just going to blindly start destroying things and recreating it as long as you're following that plan process.
Thank you. Another question around the Kubernetes piece. So can you maybe talk a little bit about the difference about why you use Terraform versus like the kubectl commands?
I guess it depends on what do they mean by using the kubectl commands. There's a lot of custom resource definitions. There's a lot of things that are out there we can do. I think Google came out with config connector and some other things where you can deploy cloud infrastructure via CRDs. I think it really depends on what you're trying to accomplish, right? I mean, if you're a small shop that you're running 100% microservices, everything's containerized and everything's in Kubernetes, that might be a good workflow for you, right? And we're going to help enable that. But a lot of the organizations and enterprises that we work with, they have large on-prem presence, right? They have multiple data centers. They have potentially multiple cloud providers that they're working with. And they might be running AKS or one of these managed services. They might be running a number of different cloud services outside of Kubernetes. With Terraform and our tools in general, it allows us to wire all of that together, even though it's maybe not specific to just Kubernetes, right? So I would just kind of say that if you're a Kubernetes shop and everything's decomposed into microservices and running just in Kubernetes, that might be fine. But that's not the majority by any means. The majority of our customers have a very dispersed, complex environment, which we can wire across the board. So.
Awesome, thank you. Some excellent questions coming in here. I'll give it a second, see if we have any other ones come in. While I'm waiting for that, I do want to remind everybody that yes, this webinar is being recorded. We will be publishing the recording of the webinar as well as the slides on our website, usually within like 1 to 2 days. I'll also be sending out an email link when that is available, and you'll see it posted on our social media. So Doesn't look like we have any other questions coming in. So with that, I want to thank everybody for joining us today. I really want to thank Troy, Sean, and Mayank for taking the time to present to everyone today. And if you have any other questions, feel free to reach out to any of us directly. And again, as Troy mentioned, his code for his demo is available publicly. And as I said earlier, we'll be posting the recording and the slides for public consumption, usually within like 1 to 2 days. And with that, I hope everyone has a great rest of their day. Thank you all.
Thanks, everyone.